Okay, another day of front-end interview questions. So this problem asks us to serialize a binary tree and then deserialize it. So basically restore it back to the tree. So the serialize should produce a string actually. So this array example here will be a string find. And the deserialize would take the string output and then restore it back to a binary tree with this no data structure. So obviously we need some sort of traversal algorithm to go through the tree to generate the serialization. And there's at least three different types of traversal you can do. There's preorder traversal, which we go all the way down to the left subtree, right, and then go to the right and then left, right, and then repeat. And then in order, which is per level. So we go 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And post order, which is the reverse of a preorder. You go from the right subtree to the left subtree. So to make this easy, I'm just going to pick one of the traversal algorithms. It doesn't have to be. Your implementation will change based on which traversal algorithm you pick. But for simplicity, it doesn't matter. I think in order traversal would be easier to understand because you can do left and right. So you can detect the left and right children by looking at it as a heap where you do you look at the index of the array, your output. But I think that's a bit too straightforward, so I'm going to actually use preorder traversal and try to do this in a recursive fashion without using the property of the children. So pretty simple recursive recursion here. We're going to write a helper here to do preorder traversal. So there's a preorder traversal here, and we're going to take the root. And what I'm going to do is say if the root is null, right, then just return an empty string. So here's how we're going to construct the serialization. So we're going to call this preorder traversal helper on the root, and we're actually going to give it passive initialized value, which is going to be empty right now, right? Because you start from the top, it's empty, and it should give us the output at the end of this function, and then we're going to return this output. That's the purpose of this helper. So for example, if there is nothing, right, then like for example, if there's just null, because you don't have, your root is empty, then just return nothing. Or we can actually put null here for like one-to-one mapping to make it easier to understand. It doesn't really matter. You can use any value you want as long as you know what the value representing null is. You can be A, B, C, right? But for simplicity, we just do null here. And so we return null. If not, right? Actually, what I would do is we don't want to just return null. Actually, we can return null for now. Okay, cool. And then we want to do the traditional preorder traversal on the left subtree, and then preorder traversal on the right subtree. This is the standard preorder traversal algorithm, and you process the value before you traverse. So in this case, if it's not null, we want to say, okay, my output, I'm actually going to store a new output value here. My output is going to be this output equals da value, I believe. Yes. Okay. And so we also need to pass this output back here. So what we say is, okay, if you're not null, so let's say 1, example looks like this, we get 1. We add output to, so our output will be 1 right now, and we're going to traverse to the left. And this is going to give us another output, right? And actually, I think here we actually what we want to do is we want to return output concatenated with the new value, right? Do it like this, and yep. And then here we also want to do something. We want to add a comma as a the eliminator. You could do anything you want, but we can put a comma. Do another one here, right? And this will produce something that looks like a string that looks like actually looks like this. Cool. So we do the left and right traversal as well. We want to, so we get null here, right? And we have 1 here. So this will returns null. Yes. Actually, let me think about this. Yes. So what happens is we do 1, our output currently looks like this, but here we actually pass this into the function, and we're going to read this, put null, and it's actually going to return us back 1.null like this. Yeah. And then what if I just return null actually? Let's just return null. Right? If I just return null here, then this will give me back null. The output here that I feed into here would be 1 comma, put null, returns null, and then I can just append that value at the end. Yeah. Well, actually, and I also need a comma, because what if the right subtree is also null, right? So this will give me, after this output will give me 1 comma null comma, and then this other output is going to give me another null, so it's going to be null because I feed this back in here, and then it's going to be another null here, so we do that. Cool. All right, so we do it like that. And then at the end we just return the output. And then one more thing here is that we also want to, at the end, we're going to get an output that looks like this. We actually want to trim off this comma right here. So we want to trim the comma. So we're actually going to return the substring of the output length -1. Yep. And then that should give us that, and we can test this real quick. My root would be a new node with the value of 1, and the left and right child will be default to null here. So let's say console log serialize root, and let's just see what that looks like. And then 1 comma no comma no. Okay, so I think that's done. We can test it more even, so we can do left, right, and then right push new node 3. Oops, spelling error. And then try to run this again. And ooh, okay, this is interesting. So you see we actually have a problem here. So this value is wrong. Let's figure out why. This feels like it duplicates. So what's happening is this part, there's 2 ones, which is not what we want. What we should get out of this algorithm is this, right? 1, if we do preorder traversal, 1, 2, no, no, 3, no, no. But there's something funky going on here. Let's debug. There's an extra 1 here for no reason. So root value, okay. 1. Preorder traversal to the left. Okay. This should be left. So the left value of that would be 2. So it should take in 2 here. Okay, so what happens is that we had a 1 comma here and takes that output 1 comma, it produces 1 comma 2, and it adds that to this, which is not what we want. So we want to actually reset it a little bit. Well, this is not ideal. What can we do about this? So what we want to do is say, okay, I give you 1 comma. You should always give me the updated version, right? So that, let me see what this looks like. That's null. So I think I need to actually add the value here as well. Okay. So output is already comma. Yeah, there you go. Because we don't want to append duplicate values. We just want to reset the output to the newest values. And that's why we need to update this, because this is the terminal case. We can take our current output and add a null to it and end it. And that's our whole entire. So basically, because this part ends the string and it appends null to it, and then we can just reset the output string here to that new string instead of adding duplicated values. So this is exactly what we want, right? Yep, perfect, cool. Now let's write deserialize, right? So for deserialize, it's interesting. We actually have to go through preorder traversal again, but this time we have to build the actual array. So first of all, we need to split the values. So our delimiter here was a comma. We can also make that anything, like a sidebar if you want, but depending on what your delimiter is. Let's see if we can split by comma right now. So our nodes would be the string split by comma, right? And then, so then we will have results like 1, 2, 3, no, 3, no, like this. And we want to write let me write another helper function for this. So we want to write another function called preorder traversal and preorder deserialize. Sure, let's call it that. And then it's going to give you the number of nodes here. Because when you're dealing with the array, we might also need the index to keep track when we're done. Maybe. don't know that yet, right? So actually here we're gonna call it preorder deserialize nodes starting I. So we're starting from 1 here. And we can say, right, because we will never have the case. We will never have the case where you're gonna get this on its own, because it has to be followed by null, right, or valid values. So for our base terminal case, it can just be if nodes I equals null, right, just return null. Don't have to make a new node. Else, right, we'll make a new node, or yeah, just call it node, new node, the node's value. And then we want to run this function to deserialize the left subtree, and then it has to also deserialize the right subtree. But here's the question: what is the I value, right? So what happens is we already processed this value 1 here, and so for our left subtree, it's gonna start with 2, right? 2 and something else. We don't know what that looks like. Anywhere here could be a left subtree of 2. And this left subtree recursive algorithm will take care of that, right? It'll go 2 to 3 to null, and then we increment the index every time. So we need to finish this somehow, and then we run on the right subtree, which is going to start here, right? We need to somehow know, okay, this is a new index to start this right subtree. So what actually happens is after this function is done, we need to know, hey, what's my new index, right? The right index to traverse, because then I can traverse the right index. Also, this should give me back a left node to attach to my node here. So, and then in the right subtree, we're done. So we have a right node here and a another index that we don't really care about at the moment. So, and then after those traversals are done, we attach the right subtree. Guess I can just call it right tree to make it more clear. Left tree, and right is the right tree, right? And we have to make the return type the same. So actually here, just pass null I, and here would be the node. And sure, whatever index this could be. Whatever. So call it foo. Doesn't matter. Foo. Alright. And then so here we get the root, and doesn't matter what this value is. Don't care. And return the root back. Right. And for the terminal case, what if we hit the end of the array? For example, what if we have something like, so I think we will actually never have to check for that case, because the end of our array is always going to be terminated by a null. So this basis case is always covered, right? It's always covered. So because you can only have stuff like this. You cannot have a valid binary tree serialization that looks like this. It has to be followed by null. So it has to look like this. So let me see what that looks like when we deserialize this. So actually, here's the, let's just say this is the serialized version, root, and this is the deserialized version of the root. Let's just see what that looks like. Oh, console spelled it wrong. Run it. Okay, so for this case, we have left, right is no. Okay, so in this case, our right is wrong. Why is that wrong? Oh, I think this is another +1. Yeah, there we go. Else we just did the same thing on the same node. Okay, so here we have value 2, value 3. Okay, and then see if I submit this. Perfect. Oh, that's it. Thanks for watching.